SaaS companies lose approximately 5 to 7% of annual revenue to customer churn. This project represents a deployed interactive application that will predict churn risks and estimate customer life value to help identify and prioritize high value customers for retention. At the end of the project, be able to prioritize high value at risk customers, shift from a reactive to a proactive retention, and identify and fix product friction. Okay, let's head over to our life prediction. So we can see we are click and addicted, added senior citizen. It has a partner and some features like the customer uses a fiber optic internet service, also uses also stream movies, also have no online backup, no online security, no tech support, and no device protection. And then the total charges is about $780, and the monthly charge is about $180. And then when we click on the prediction and CLV, we have the prediction result to be about a 71.9% probability that the customer would churn, and this is also a high risk probability. And then we have the customer lifetime value to be about 4,320, and then the retention value at current risk is about $1,208.48. Okay, let's explain our prediction result further. We can see that we have a model divergence of a logistic regression to be about 99.6%. So this model is almost certain that the customer would churn, and it likely picked up on a strong linear indicator of about a zero login and 30 days. And then we also have an RF and XG boost average of 65.2%, and this model are more conservative. They'll look at a complex pattern. So, and Aaron as Alamis as the logistic model. And then we also have the risk level, and this indicates that there is a high risk of the customer to shown their product, and we need an immediate intervention like an email, a phone call, or a specialized discount for the customer to be retained. Let's explain our customer lifetime value, and then we could see that their estimated CLV for the customer is about $4,320, and we also have a retention value at the current risk to be about $1,007.27. And then as we could see that with our calculated logic that there is about a 76.7% chance that the customer would leave, and we are losing about 77% of $4,320. So the 1,007.27 is what we can actually calculate and count for if we do nothing. Okay, let's head over to the model performance comparison. We have the top performer here, which is the random forest, which has the highest overall accuracy, and the base AUC to ROC of about $0.8442, and this makes it to be the most robust general purpose model. And we have the base for catching the churners, which is the logistic regression, which actually has the highest recall of 79.68%. In a SaaS context, this is often the most important metrics because it means that the model catches nearly 80% of all the customer who actually leaves. And then let's head over to the metrics, performance metrics. We have the overall accuracy to be for the random forest, which is most accurate model, which is about 77.08%. And then we have the recall of the logistic regression to have a 79.68% is the best at catching the actual churners. So this really identify almost 80% of everyone who actually left. And then the AUC, the ROC, we have all the models score between 0.83% and 0.84%, which is considerably excellent, and it proved that my model is strong, stable, and reliable. Finally, AI assisted me a lot in data pipeline debugging and code fixing, and I use GitHub Pilot for that, and also use the Claude AI for algorithm optimization and conceptuals. I also use um, GitHub Copilot for problem solving and identifying data leakage in my future engineering. Thank you.